Volume under a plane. Here we have the intercept form of a plane equation, x over a, y over b, z over c. Add this together to get 1. Has x-intercept of a, y-intercept of b, z-intercept of c. Pretty easy to see where this comes from. Right here, y and z is 0. Drop out these terms. X over a equals 1, x equals a. Same thing for y and z. It's also useful, we'll find it useful in this problem to find this line. That's x over a plus y over b equals 1. We're in the xy plane, z is 0. Just drop that term out and that gives you this equation. So in this case, we want to find the volume under 2x plus y plus 4z equals 8 in the first octant. The first octant is where x, y, and z are all positive. That's right here. So the volume under the plane is bounded by these three planes here. Technically, the volume underneath the surface would be infinity because we could go as low as we want if we weren't bounded by these three coordinate planes. First of all, we're going to divide by 8 on both sides of this plane equation. That gives us x over 4. That gives us y over 8. That gives us z over 2. 8 over 8 is 1. We can sketch the intercepts 4, 8, and 2. Okay, you can find the intercepts just by letting y and z be 0. 2x equals 8, x equals 4. Same thing for y and z. But this intercept form can be convenient at times. So then we end up with x over, slight correction here, that's 4. Plus y over 8 plus z over 2 equals 1. Drop the z term out, we have this xy equation, that's this line down here. Now it will also be convenient, you can solve for y in terms of x. We have 8, 1 minus x over 2. Move this over here, multiply by 8. And you can also solve for z up here. 2 times 1 minus x over 4 minus y over 8. That's all useful for future reference. Now the volume equals, we're going to set up a triple integral dz dy dx. And you may remember before, it's useful to set up a integral in the xy plane first of all. And so we're going to set up an integral over this triangle. If it helps, you can, let me do this in black, you can set up a xy coordinate system. We have an x-intercept of 4 and a y-intercept of 8. That's that triangle. It makes it a little easier to set up the double integral portion of this. And then x is going to go from 0 to 4, y is going to go from 0 up to this curve. This curve happens to be y equals 8, 1 minus x over 2. You can even distribute the 8 out. 8 minus 4x, if you wish. And now we're going to set up the volume integral. First of all, we start with a double integral over this rectangle. X goes from 0 to 4, and y goes from y equals 0 up to this curve. You can use this or this. I'll use 8 minus 4x. Okay, so we integrated over the triangle. Now z has to go from the lower surface to the upper surface. The lower surface is z equals 0. The upper surface is simply this plane right here. And so I'm going to multiply this out to simplify a little bit. 2 times 1 is 2. 2 times x over 4 is a half x. 2 times y over 8 is a quarter y. And that's our volume integral. That should give us the volume of this tetrahedron. This is a simple volume formula, by the way. It's actually 1/6 ABC. we could calculate that, but doing the integration adds a little bit of fun to the subject. And it's interesting, if you were to make a cube, you'd have to complete this whole cube. This volume is 1/6 of the cube, actually. You kind of cut the corner off, it gives you 1/6 the volume. It's an exact relationship. If you were to do the whole cube, you'd have to complete this base here and complete this. It would be just ABC, length times width times height. Okay, let's evaluate this integral. We'll see if we can get part way through. It's a simple integral, but tedious. Integral 0 to 4, integral 0 to 8, minus 4x, z, from 0 to 2 minus a half x, minus a quarter y. And let's clear some space over here. Well, plug in that, plug in 0, you just end up with this polynomial in here. Integral 0 to 4, integral 0 to 8 minus 4x, 2 minus a half x, minus 1/4 y. Okay, I forgot my dy dx here. Now we have to integrate with respect to y, so that's 2y minus a half xy minus a quarter y squared over 2. Integral 0 to 4, 2y minus a half xy minus a quarter y squared over 2, from 0 to 8 minus 4x dx. Now this has to be substituted wherever there's a y, so we have integral 0 to 4, 2 times 8 minus 4x minus 1/8, quarter of a half is an eighth, dx. Okay? You can multiply all this out. I would probably do all the polynomial work, FOIL that, take an eighth of that, distribute that, combine the like terms. And doing all that in my head and doing the integration, I can see the answer is 1/6 times 4 times 8 times 2. Okay, and that is equal to 64 over 6. You can divide 2 into that, 32 over 3. That's what it works out. I'll leave this tedious part to you. I have no interest in doing that right now. You can see the way to that. This is just a calculus 1 Jauzi integral, so you can work on that. Okay, that's all there is for volume for now.